So in this video we are gonna solve question number 98, validate binary search tree of Leetcode. It's a medium level question and it is a very good question to understand in order traversal and how in order traversal is linked with binary search tree. And yeah, some of the interview has this question directly, they ask it directly. Many of them ask indirectly, or it will help you to solve any other kind of question related to BST. Okay, let's go and see what the question is saying. Given the root of a binary tree, determine if it is a valid binary search tree or not. BST basically. What is a valid BST? They defined it as the left subtree of the node contains only nodes with the key strictly less than the node's key. What is the key? Key basically means the value. The first statement is saying whatever in the left of this node should be having value lesser than this node. Yeah. Okay, and the right subtree nodes contain only less than like greater than the root one. Okay, similarly the 2 is here, everything on the right of the true should be greater than the true 2. If this both condition are satisfying, and here also after that also 3 right should be greater than the 3, 3 is left should be smaller than the 3. Similarly here 1. If we are following these three things, then we have a valid binary search tree. Okay, in this case you can see 5 has the 4, so it is not a valid binary search tree, and they even mentioned that also. How we will solve this question? Let's quickly see it. But in the interview you have to explain your approach, and the main motive of my videos are understanding how you have to speak, how you have to translate, or how you have to communicate your thoughts to the interviewer. So the first thing after seeing this, you should think about, we have to do a traversal. We have to do traversal from the leaf, like from the leaf to the leaf, and the traversal should be in the ascending order. So traversal should be in ascending order. Okay, that's the first thing which you have to notice in this question. Another thing which you can notice is, see, we have to visit leftmost, and leftmost was 1. Then we visited the root, or you can say middle. Middle was 2. And then we visited the rightmost, and the rightmost was 3. You can see we have a ascending order. We have a ascending order. And what we call this? Left, then middle, and then right. Can you see? This is in order traversal. This is in order traversal. Yeah. So if you don't know in-order traversal, see a basic video of in-order traversal, then you know how it works. So in-order traversal basically says that first you go to the leaf node, like this leaf node. Then after going to the leaf node, this leftmost node, you go to the right, like middle of that. So this is the middle of the this node, and then you go the right. So 3, 4, 6. In this way you should go. Okay. Suppose in this big tree, what will happen? It will go to the 1 first, then it will go to the 5. For now, suppose this is not here because this is not a binary search tree, so you don't think like that. So just understanding, for your understanding, it will go from 1 to the 5. From 5 it will go directly to the 3, and from 3 it will go to the 4. From 4 it will go to the 6. Okay, this is how in order traversal work. Let's code it. It's pretty simple. Let me keep this here itself. Okay, how we will approach basically, let's see, we have to return answer in a boolean form. So let's just create private boolean answer is equals to, uh, for now by default, suppose if it is a BST, it will traverse all the nodes, like O of n will be the time complexity, then all the nodes will be going to be traversed. So we can say that, let's just keep it true. If it will fail somewhere, we will make it false and return. Okay, and one more thing, we have to keep monitoring the value. So when we visited left, the value was 1, but when we visited the middle part, the value increased. So in any case, when we move from left to middle or middle to right, sorry, from middle to right, if value is not increasing, instead of increasing it is decreasing, then at that point we know that BST is failed and we have to return false, because that's not a binary search tree then. Okay. So yeah, that was the logic of this question. If you now understood the logic, you can go and solve your own, and then you can come and check here. If not, just keep stay with me. We will solve it. Let's do it now. We are solving it, not solve it. Appa. And now, okay. So what we can do is we can call a in order helper kind of function. We will create it here itself with this root, no issue. We will call it with this root, and yeah, just return answer here, nothing else. We will handle base condition in our that function itself. So let's write that function private. Okay, we don't have to return anything from this function. We just have to update this answer if we hit any kind of failure. Okay, so what we will do, we will create it as a void in order helper, and you can say it's like tree node. Okay, and now base null condition again. You should ask interviewer that, suppose sir, I have only one node, or there's only no node in the tree, what should I return? So in this condition, if there is no node in the tree, if, sorry, not root, node equals to null, then we can just return this, just we can return this function. So by default it will return true, no issue. Okay, otherwise we have to do in order. Suppose it is not null, in order what, in order traversal, now we have to do in order traversal, but in which direction? In left direction. First we go in the left direction, so let's write in order helper, and we will just do node dot left. It's pretty simple, and no, now the main logic will come. So in order traversal, this is the center point now. Center point. So center point is like this middle part. So what I told, when we went left, we got a value. Then we came to the right. Okay, in the right, that value should not be smaller than this previous value. Okay. Okay, so we need to keep updating value also. So we will create a function, like not a function, sorry, a variable to keep storing the value. But before that, note this thing. Always see the constraint. It is bigger than integer, so we have to use long. So we will use long, and yeah, we have to store the like, what you can say is the previous value. We have to keep storing it. So we will just say prev value okay. So pref value, and we should make it like a long dot min value. Okay, I hope so you know what long dot min value means. If not, just Google it. You should Google everything. That's how we learn. Okay, yeah. So here our main condition will come if over this node dot val, basically node dot val, I will tell you why we will use this pref value. Okay, if this node dot val is less than our pref value, as I told previous value, if it is less than our previous value, and why we are not putting only, we should only put less than, is it correct? No, it is not correct. Read strictly less than. Strictly less than means it should be even, it should not even be equals to also. If it is equals to and less than, then it's wrong. We can't use it. We can't call it BST. That's what the question is saying. Okay. Then what we will do, if this is the real condition like we are facing, then we will do is answer, we will make it false. We will make answer false, and we will just return. Okay, these two things we will do. If suppose everything is fine and we can move forward, in that condition we have to update our minimum value, like we have to update our previous value. So now prev value will be become your node dot val value. Okay, but here I will say, let's just keep that mat dot max of prev value comma node dot val. Okay, we will keep like this, just for I think so some edge cases will hit. Otherwise we will try with that also. Okay, let's Curiosity, you have to run and test, no other option. Sorry. Yeah, so this is the thing. And if this is fine, then we can just travel in right direction also, correct? So travel, sir, now in right direction. So what will be the function in order helper, and we can just say node dot right. Pretty simple. Let's do the dry run, because dry run will going to tell us a lot of story. So first I call the in order helper on one. So let's just do one. Then what happened? One from, sorry, not on one. My mistake. It got called on two. From two, it checked like node is not null. Yeah, it is not null. No, it's two now. It went for the left part. So when it went for the left part, it came here. When it came here, what is our current value? It will be the one. Then what happened? It checked. So minimum value and all, the condition passed, because this will be smaller than 1. So yeah, 1 will be our minimum value. Then what happened? Then it went the right. So when this done, this part done, it went for the right. So right of 1 is null, left of 1 is null, it will go back. So back when it comes on 2. So now we have 2. And when we do this check again, let's do this check. So our minimum value was 1, but now the value is 2, which is greater than that. It means it satisfies BST. So we will move forward, and now our minimum value will be 2. Similarly, now what will happen once you reached 2? Okay, after reaching 2, you should go right. See, we went left, we reached now back, middle, and now we go right. So when we go right, we can see in right node, this function got called again. It's not null. We can have left. No, we don't have left. So it will return back. We have right. No, we don't have right again. It will return back from here also. And if we check this main part, here we can see 2 was the minimum value. Prev value means, and 3 is greater than prev. So our answer is currently true only. And yeah, so we will have 3 also. And through this we ended everything, and from here we again return back to this point. And once we reach this point, now we can submit our answer. Let's do. Okay, we faced a issue. Let's see. Int cannot be converted to long. Okay, that's the thing. Okay, so yeah, I made a mistake. The mistake was here. So here it was this caps lock L. It should be long. It should be like primitive one, not the non-primitive kind of. Okay, and after we did that, it worked. So you can see here, 100%. Yeah. So thank you for this video. I know this video is little bit less, like less in the length compared to my previous one. But the point is, this question is a medium level, but the way to solve it, the way to approach is was simple. We have to just do in order traversal. So the logic says is, whenever you have a BST and you will do a in order on a BST, you will get ascending order values, ascending order values. So this is the main logic, and on the basis of this logic, we form this whole code. Okay, let's just quickly see time complexity. What will be the time complexity? Worst case time complexity will be when you are BST, when you have a binary search tree, perfect one. It will be, you will be going to traverse every node, so it will be O of n. Number of nodes is equals to n. Okay, and what will be the? There will be one more thing, space complexity. The space complexity will arise because of this. We are assigning some values and we are changing some values, because of which space complexity will also come. And how many times you have to assign value in this prep value? The height of the node, whatever the height of the node, whatever will be the height of the tree, that will be the worst case thing. That much many time you have to append, like change the value in this prep value. So O of h, height of the tree represented as h. Okay, but in normal case it will be log h, yeah, log n you can say. Okay, So I made notes also for you. Let me just quickly show. So here, see, O of n is your time complexity because we are doing constant time operations. Okay, assignment, recursion, and all. You can learn more about recursion stack because interviewer ask what is recursion stack and how it is working in your code. At that time, you have to show them. Okay, otherwise the space complexity is the simple part. As I told, worst will be height of the tree, so O of n, and balance will be log n, or you can say O of log h. Okay, so that was the question, and that's how we approached and we solved it. The main thing behind this video is this is how you should solve in your interview. You have to keep speaking, you have to keep communicating with the interviewer, you have to understand edge cases. If you don't understand the question, you have to ask him many things, and then you have to start writing your solution with proper commenting so that he can also understand. And you have to keep explaining why you are doing this, why you are doing this, like we did. So this is not just about how to solve it, it's about how to express yourself also. So I hope so you enjoyed the video. All the best.